So we've been looking at the normal distribution, and we are familiar with the fact that when we have got data distributed normally, that 68% of that data falls within one standard deviation either side of the centre, which is the mean, the median and the mode. We know that 95% of our data lies within two standard deviations either side, and 99.7, nearly all our data, but not quite all, lies within three standard deviations either side. So then we went on to have a little look at how we could work out the separate parts if we wanted to work out probabilities of to work out the areas underneath the curve. So for example, here we know that this middle section is 68, the whole section. So we could split that in half. So we've got 34% and 34%. So our important numbers here, just to recap, are 68%, 95%, and 99.7% within three standard deviations. So once we know that this whole section here is 95%, we could do a little calculation. 95% take away the 68% that makes up the middle, leaves us with 27%. So if we share that leftover 27% between this one and this one, each of those will be half of 27% or 13.5%. And then finally, we know that 99.7% of our data, sorry, I've got a creaky door, is within three standard deviations either way. So if we were to do the calculation, 99.7 take away 95, that leaves us with 4.7 left to share between these two bits here. So half of 4.7 is 2.35. So each of these are 2.35, 2.35. And if we divide the remaining 0.3%, each of these bits here are 0.15. So my diagram looks a bit messy now, but I think if we look at this one, it's a little bit neater. And it just recaps some of the stuff that we have talked about. So this example we've looked at already, but we'll just recap. Hopefully you're all familiar by now with labelling your curve. So just turn on the pen. The contents for a tin of chickpeas has a mean weight of 400 grams. So the mean weight is 400 grams and the standard deviation is 15. So each time we go up by a standard deviation, we're adding on 15. So 415, 430, 445 grams, and then going back we'll take off 15, so 385 grams, 370 grams and 355 grams. So we are trying to look at what weight, above what weight will 97.5% of the tins be, so most of the tins. So it's important just to think carefully about what the question's asking so we know which side of the graph we're looking at, but we're going to be looking over this side because most of the tins are going to be above this weight. So we know that 68% of these tins will lie between 385 and 415 because of the numbers that are useful for us to remember. So 68 within one standard deviation either way, 95% within two standard deviations either way, and then that 99.7 within three either way. What's quite useful here is 95% because we know that these four middle parts all add up to 95%. So what that means is that we've got 5% left, 100, the whole curve makes up 100%. Take away the 95% gives us 5% left. And if we split that, if we divided that between this part here and this part here, each of those would be 2.5%, and that part would be 2.5%. So if we want to see above what weight 97.5% of the tins will be, I hope I said that correctly, we know that 100 take away 97.5 gives us 2.5. So if we look at this point here, which I haven't drawn very straight, if we add everything up above there, that will be 97.5. We could think of it as 95 plus 2.5, or we could think of it this way as 100 to take away the 2.5. So the answer to this, above what weight will 97.5% of the tins be? The answer is 370 grams. And I think the next slide will probably show it a little bit more neatly. So if my diagram doesn't make sense, hopefully this one will do. Then we started looking at what the notation we could use. And do you remember we realised that we could write it like this? Let me get the pen working. And this means that it's a normal distribution, and this 8 represents the mean. And this 0.2 squared is the variance. But if we want the standard deviation here, I don't know why I'm writing it long, deviation is 0.2 here. So our mean is 8 and our standard deviation is 0.2. So the answers are on the next slide, but for example, if we're working out the probability that x is greater than 8, we know that the mean is 8, so we're looking half the data, half of it is going to be greater than 8 and half of it will be less than 8. So you can see here, if we draw a diagram, 50% of the area lies above the mean. So the probability that x is greater than the mean is 50%, or 0.5. And then the next one, the probability that x lies between 7.8 and 8.2. Well, we know that the standard deviation is 0.2. So 8.2 is one standard deviation up from 8, and 7.2 is one down. And because we know the values, the 68, the 95 and the 99.7%, we know that one standard deviation either way means that 68% of the data is in between that. So 0.68 is the probability of it being within there. And another similar question that I think we did look at. So similar thing, here our mean is 100. So if we're to draw our curve, we'll stick that in the middle. We know our standard deviation is 15. So we could label in between here, we could have 115, that's one standard deviation up, and we could have 85 here. So we can see that actually between 70 and 130, that's two standard deviations either way. So the probability of it lying within there is 95%, because we know our numbers. So two standard deviations either way, the chance of it lying in between there is 95%, or 0.95 as a decimal. And then the chance of it being greater than 115. So looking at our chart here, we know this is one standard deviation up. Another way of thinking of this is that this whole right hand side is 50%, because 50% of it is above the mean, and we know this small part here is 34 because it's half of 68 and our curve is always symmetrical. So if we take off the 34, we're left with 16%. So 16% of our data is going to be above 115. So the probability of it being greater than 115 is 16% or 0.16. So the next thing that we are going to look at is our statistical tables. We know that our bell curve, that the area underneath the whole thing is defined as 1 or 100%. We've also just looked at the notation, which tells us that here the mean is 0 and 1 is the standard deviation. And there's 3 different cases we can consider, and again a diagram is very helpful. So the first one is Z is less than a certain value. So in this picture here you can see we're looking for this shaded area here where Z is less than A. The second one, Z is greater than a value. So in that one here, for example, if it was greater than A, and A can be anywhere along here, but in this case it's on the right hand side, we'd be looking for this area here with the question mark, because that's the bit that's greater than. And we could even be asked to find when Z is in between 2 different values, so this shaded part here. So that's why this is where the diagrams are really useful to draw. This is an example of what the statistical tables look like. I haven't got all of it in because I couldn't fit it all on my slide, but you will get a copy of this in the exam, and you should find a copy of this to work with while you're doing these questions. So here's an example. We are going to look at our normal distribution. It's telling us we've got our normal distribution mean 0, standard deviation 1, and we're going to find the probability that Z is less than 0.31. So in this case here, we can imagine that Z is 0.31 and we're looking for this shaded area on the left hand side. So what we need to do is find 0.31 in this table, and we do that by using this left hand side for the first part, the 0.3, and then this top part here to get us the 0.01, because we make 0.31 up from 0.3 and 0.01. So we look along our table at 0.3, we look down at 0.01, and there we go, this is the value that we're looking for. And this gives us this shaded area of P and the answer to the question. So 0.62172. You might not always need to give it to 5 decimal places. 4 is perhaps more common. So the next one, I seem to have left an arrow there. Similar thing, but this time we're working out the probability that Z is greater than 0.31. So we've just worked out the shaded part on this side, and that's what this table gives us when we find our number. But we want to work out the probability that Z is greater than, which is on the right hand side. So the way we do that is we know the whole area is 1. So we do 1, take away the shaded bit, the 0.62172 that we found on the previous slide, and it gives us this answer here. So if we're looking for the bit on the right hand side, we can just subtract the shaded bit from 1. And another example, again I've forgotten to add the animations in the correct order, but never mind. Here we're looking for the probability that Z's in between 0.1 and 0.31. So it's this part here where the arrow's pointing. And so to do that, what we need to do is work out the probability of this whole left-hand side less than 0.31, and then take away the part that's less than 0.1, and then that will give us what's left, will give us the answer. So the way we can do that, we've already been looking at the 0.31 in the previous 2 slides. We are going to subtract the probability of Z being less than 0.1 which is here on the table. So it's just 0.1. We could say 0.10 if we wanted. And that's 0.53983. And then we're going to do a takeaway. So this one subtracts this one, gives us 0.8189. So that's how you work out if you've got to be between two different values. You work out one of them and subtract the other to give you the bit in the middle. So this is another example. In this case, we are looking at the probability that z is less than -1. So here, this is where we use the symmetry of our curve. So imagine that this is 1 here and that this is -1, and we're looking for this part here, which we can see is the same as this size here. So actually, if we just work out the probability that z is less than 1, which is here, and this value here, so the probability that z is less than 1 is 0.84134. So that would be this shaded bit, if those red marks weren't there. So then actually to find this bit here, we just need to do 1 take away that value. So 1 take away 0.84134, which I'll get my calculator quickly. 1 take away 0.84134, and that gives us 0.15866. 0.15866. There we go. So now I'd like you to have a go at these questions on here. You might be able to read the distributions, the numbers on the right hand side. If not, grab yourself a table, a set of tables. There's probably some in your book, or you can get one off the AQA website, or probably anywhere on the internet, and have a go at these questions on the left. Then pause the video, and when you think you've got some answers, have a look at the next slide. You can play again. Do remember to draw diagrams, because that is super helpful when you're doing this. Here are those answers. If there's any you're not sure on, maybe flip back to the video, rewind, if that's still a thing, and have a look and see if watching some more examples will help you.